Very good morning, my dear students. I hope everybody is doing very well. Let's start another session of these online classes. We had discussed so many chapters belongs to your first PUC as foundation level basics, starting from motion in one dimension. It's also called kinematics, motion in a straight line. Then we had started a chapter called gravitation. In the gravitation, motion under gravity concept is also discussed. Recently, the chapter called force and loss of motion till the NEET, KCET, JEE mains level basics we had finished. Now, here I have come with another topic called work, energy and power. Work, energy and power. So this is the chapter you had studied in your 9th standard. And this is the same chapter is available in your first PUC also. And you'll not believe this is the chapter where in your NEET exam 2 questions will be asked from this chapter. 2 questions. If it is a CET exam, there will be 1 question asked. Even in JEE exam also 1 question will be asked from this chapter. And the most importantly, there is a topic called energy here. In this energy, you might have studied in the lower classes, there is a topic called a law of conservation of energy. Law of conservation of energy. And this law of conservation of energy will be applied in most of the topics of your first PUC and a second PUC topics even. Whatever may be the chapter or the topic, in most of the topics you can apply law of conservation of energy topic in first PUC and second PUC topics. So that much importance is there for this. And in some cases, you will be seeing or you will be observing once you start your first PUC and second PUC topics, we can simplify the numerical by using the topic called law of conservation of energy. Law of conservation of linear momentum we had finished. Law of conservation of linear momentum we had already finished in the last chapter, where total linear momentum of the system remains constant, whereas law of conservation of energy, the total energy of the system remains constant, right? The energy neither be created nor be destroyed. It just takes from one form to the other form. The same way, law of conservation of linear momentum. The linear momentum cannot be created, neither be created nor be destroyed. It just transfers from one body to another body. That was law of conservation of linear momentum, and this is law of conservation of energy. And in this session, that means in this chapter work, energy and power, we will be discussing about law of conservation of energy also, including the numericals. I hope you understand the importance of the chapter, right? These are the basic level till NEET, JEE and KCET we will be covering in these sessions. Once we start our actual first PUC, again we will be discussing the brief way these basics, then advanced topics we will be starting. And again I am telling you, these are the basic concepts we are using which will be useful for our actual first PUC topics, right? I hope you are very clear about this session. Now let's start. And if you see the name of the chapter here, work, energy and power. There is a common thing among all the three names here. What is the common thing? The common thing is that work is a scalar quantity, energy is a scalar quantity, and this power is also a scalar quantity. Is it clear? So work, energy, power, all are scalar quantities. All are scalar quantities. So what is meant by the scalar quantity? The quantity which has only magnitude, right? Is there any direction for this scalar quantity? There is no direction for this scalar quantity. Clear? Only magnitude. So work will be having only magnitude, energy and power, only magnitude. That's a scalar quantity, right? Clear? And before starting this work, energy and power, especially our first topic is work. So to understand the concept of work, you should understand the basic trigonometry. The basic trigonometry. So mathematics, right? Basic trigonometry you should understand. See here, mathematics is the machine language of physics. Remember, mathematics is the machine language of physics. What does it mean? Why we are talking about the mathematics here? Look at here. Work. To understand the original concept of the work. See, work is equal to force into displacement. Such kind of definitions also I can give and you can discuss. But that's not our aim of the class. The aim of the class is to give you sufficient foundation concepts to start your first PUC, right? See, work, to understand the detailed version of this concept work, you need to understand the basic idea. You need to have the basic idea about the trigonometry. Trigonometry belongs to mathematics, right? So that's the reason I just wanted to tell you the relation between the physics and mathematics, right? So mathematics is the machine language of physics. For example, if I write F is equal to MA, look at here, there are some mathematical symbols and there are some mathematical symbols and physical quantities involved in this expression. What are the physical quantities? Physical quantities are force, mass, acceleration. What are the mathematical symbols here? Is equal to and multiplication. Carefully you see here. There are some physical quantities and mathematical symbols. Everything is involved in a single equation here. So these are the physical quantities and these are the mathematical symbols. Is it all right? See, for example, if I remove these mathematical symbols, what happens? There are only physical quantities left, which is F, M, A, right? Is there any meaning for this combination of these physical quantities F, M, A, right? So there's no meaning. So when we remove the mathematics from the physical formula, there won't be any meaning. So that's the reason mathematics is the machine language of physics. Physical quantities and the equations can be explained in an effective way only by using mathematics. So that's the relation between mathematics and the physics. That's the reason in another track you are learning a basic mathematics which will be helpful for your first PUC and second PUC. Clear? So this is the mathematics, is the machine language of physics, right? All right. So let's concentrate on the basic trigonometry which you had already learned in your 10th standard. Okay. So basic trigonometry. See, there was a huge gap in learning this trigonometry by you. In 10th standard you have done. After that, so many days holidays and the exams were postponed, and finally you wrote the exam, you had come up with a good result, right? So everything is done. Now let's quick recap about this basic trigonometry. See, there is a triangle I had considered. This is the theta, is the angle between this side and this side, right? So between the hypotenuse of the triangle and a base of the triangle, it's a height, base and hypotenuse. Clear? Now, this is the theta I have. Carefully if you see, for this theta, and this is the opposite side of the triangle. Clear? Opposite side of the triangle. And for this theta, and this is the adjacent side of the triangle. This side, adjacent side, this side, opposite side. And this is the side, it's called hypotenuse. What is this? Hypotenuse. Now, in trigonometry, you will be having a sine angle. Sine of this angle may be 0 degrees, 30 degrees, 45, 60 degrees, 90 degrees, whatever it may be. So there is sine of this angle is always equal to opposite side by, carefully see, opposite side by hypotenuse. Remember, sine angle of this triangle is opposite side by hypotenuse. If I want to write the cos angle for this triangle will be adjacent side by hypotenuse. What is that? Adjacent side by hypotenuse. Clear? Now, tan angle for this triangle, which is equal to, tan angle for this triangle is equal to opposite side by adjacent side. This is just a quick recap. Opposite side by adjacent side. And the same tan angle, I can also write it as tan theta is equal to, look at here, sine angle divided by cos angle, right? Sine angle is how much? Opposite side by hypotenuse. Look at here, opposite side by hypotenuse. This is the numerator, and denominator is cos theta. Cos theta is what? Adjacent side by hypotenuse. So this is adjacent side by hypotenuse. Carefully you see. Hypotenuse cancel, and what is remained here? Opposite side by adjacent side. So that's a tan angle. Clear? So remember, the tan theta is equal to sine theta divided by cos theta. Sine theta is equal to opposite side by hypotenuse. Cos theta is equal to adjacent side by hypotenuse. Clear? So this is what the one part of the simple trigonometry. Right? Clear? Remember. Now, what we are going to do here is, depends on the theta values, sine and cos, tan values will be various. How they will be varying, let's discuss. So we are going to focus on 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees, right? What we are going to learn now in basic trigonometry is sine 0 degrees, cos 0 degrees, tan 0 degrees. Sine 30, cos 30, tan 30. In this way, till 90 degrees we will be learning it, right? Let's do it now. My dear students, what we had discussed so far is about the basic trigonometry part 1. In part 2, what we are going to do here, let's check this carefully. So 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Alright? So these are the theta values. So here sine theta values we are going to write here. Right? Cos theta values we are going to write the same, and tan theta values also we are going to write here. See, there will be different methods in remembering all these values. So I am not saying that you have not done these tabular forms so far. You have done it. You may have forgot because your exams are finished. So what I am going to tell you is one of the easiest method to remember all these values. Right? What is that? Here, first try to remember the sine values. One of the easiest method I am telling you. Look at here. 0, 1, 2, 3, 4. Fine? One of the easiest method. 0, 1, 2, 3, 4. That's not the final answer. Okay? Wait. 0, 1, 2, 3, 4. Just divide each value by 4. Divide each value by 4. That's it. 4. 4. It's 4. 4. Clear? Apply square root for each term. So this is one term. Apply square root for each term I said. So this is the find. You'll get the answer from here. So this is a 0. Clear? Sin 0 is how much? 0. So this is 1. Root 1 is 1 by root 4 is 2. Sin 30 is 1 by 2. And sin 45 will be like this. You can see here. This is 2 ones and this is 2. Root 1 is 1 divided by root 2. So sin 45 is what? 1 by root 2. So this is what? Root 3. This is root 3 divided by root 4. Root 4 is 2. So sin 60 is root 3 by 2. And sin 90. Sin 90 is 4. 4 cancel and root 1 will be 1. Some of the students may be knowing this, a very easy shortcut method, but some of the students it may be new. But whatever, our aim is to not learn the in detailed concepts of trigonometry. Our aim is to learn the basic requirement helpful for your concept of work done by a force. How much is required for us, that much we will be recapping now. Okay, so let's see again. So theta values, let's keep 0. Sin 0 degrees is 0. Sin 30 degrees is 1 by 2. Sin 45 degrees is 1 by root 2. Sin 60 degrees is root 3 by 2. Sin 90 degrees is 1. Right? So what is this sin theta? Sin is a function. What kind of function? See, the functions will be two things. Increasing function and decreasing function. What exactly meant by the function you will be learning in actual mathematics of your PUC. Right? So, sine is an increasing function. You can see here as the theta values are increasing 0, 30, 45, 60, 90 and sine values also will increase. You can check here 0, 1 by 2. 1 by 2 means what? 0.5. Clear? So, 1 by root 2, root 3 by 2, 1. Sine values are increasing 0, 0.5, 1 by root 2, root 3 by 2, 1. It's increasing. Whereas cos is a decreasing function. Exactly, cos values will be, sine values will be reversed and right from here you'll get all the cos values. Clear? So let's start from the last, right? So what is the last one? It's 1. Then what is the second last here? Root 3 by 2. And what is the third last here? 1 by root 2. And next one, it's 1 by 2 and next one it is 0. You can see here. Just we wrote from the end. That's it. 1 root 3 by 2, 1 by root 2, 1 by 2, 0. If you closely observe, cos values are decreasing here. It's 1 root 3 by 2, 1 by root 2, 1 by 2. It's 0.5, 0. Clear? So 1 to 0 and here these values are 0 to 1. Sit down. Clear? Everyone? Right? But you will see sin 45 and cos 45 values are same. Both are 1 by root 2. Look at here. So this is 1 by root 2 and this is also 1 by root 2. 45 values are same. Sin 45 is equal to cos 45. And what is tan 45 here or tan theta here? Sin theta you know, cos theta you know. And you already learned sin theta divided by cos theta, which is equal to tan theta. Whatever may be the values of sin theta and cos theta, just divide them, you get your tan theta value. So what is the tan theta? It's sin theta by cos theta. Tan 0 degrees is sin 0 by cos 0. What is sin 0? 0 by 1. So look at here, 0 by 1, it's 0. Done? No. Tan 30. Tan 30 is equal to sin 30 by cos 30. What is sin 30 by cos 30 here? It's 1 by 2 divided by root 3 by 2. Right? What is that? It's 1 by root 3. So what is sin 30? 1 by root 3. Now, sorry, what is tan 30? 1 by root 3. Let's see, tan 45. Tan 45 is what? Sin 45 by cos 45. Look at here. Tan 45 is sin 45 by cos 45. Look at here. Sin 45 is 1 by root 2. It's 1 by root 2. By cos 45 is also 1 by root. It's 1. Okay. Now, tan 60 degrees. Tan 60 degrees is what? Sin 60. It's root 3 by 2 divided by cos 60, it's 1 by 2 and answer is root 3. Finally, tan 90 is sin 90 by cos 90. Sin 90 by cos 90. Sin 90 is what? 1 by cos 90 is 0. So 1 by 0 is infinite. It's called undefined. Understand? Infinite value. So tell me, this tan values or tan function is increasing or decreasing? Look at here. 0, 1 by root 3, 1, root 3, look at here, 1, root 3, root 3 value means what? So in your lower classes you might be learned 1.732, understand? 0, 1 by root 3, 1, 1.732, infinity. Is it increasing or decreasing function? It's an increasing function. Sine is an increasing function, tan is also an increasing function, cos is not an increasing function. Is it done? Clear? Now, this is also interesting. So finally, let's conclude all the values here. So sin 0, it's 0, 30, 1 by 2, 1 by root 2, root 3 by 2, 1. Cos 1, root 3 by 2, 1 by root 2, 1 by 2, 0. Tan 0, 0, tan 30, 1 by root 3, tan 45, it's 1 and tan 60. Root 3 tan 90, it's infinite. Is that clear? You can find the values of, for example, see, sin 0, sin 90, cos 0, cos 90, tan 0, tan 90. You may get the doubt. What happens in between these two? What happens to the values of these two in between? In between these two, in between these two, and above 90 degrees. What happened to the angles? For example, you can also find sin 35 degrees. You can also find cos 420 degrees. You can also find a tan 180 degrees and you can also find the sin 260 degrees values. And these are the things you will be learning in the basic mathematics where the physics another track is going on. So basic mathematics you will learn all these things. But why we discuss right now all these things? We have not discussed any deeper levels of trigonometry topics. Not even sin square theta plus cos square theta is what? Sin square theta plus cos square theta is equal to 1. Even that formula we have not discussed now. We had just discussed about the tabular form where you get sin theta, cos theta and tan theta values from 0 degrees to 90 degrees. Only this much we have learned. And the most importantly, the purpose of learning is very important. And simply, we should not learn whatever I know and whatever you know. So the requirement is the most important thing, right? So this is the required topic for us because while learning the work concept, I will be writing the basic formula here. Listen to me. Work done by a force is equal to force into displacement into cos theta. This is the actual formula of the work done. But what we will learn, we will just write W is equal to force into displacement. You will get 1 mark. But in reality, you should understand the actual definition of the work done by a force. And simply you should not say work. Work, simply you should not say. Work is done by what? Work is done. Always the work is done by a force. What is that force? That force may be a frictional force. That force may be a gravitational force. That force may be an external force. That force may be an internal force. That force may be anything. Clear? Maybe it may be the gravitational force and maybe a centripetal force. That force, maybe a magnetic force, whatever may be the force, right? Work is done by a force. This is F means a force. And what is this S here? I'm writing here. F is the force. Anything that force. So this S is the displacement. S is what? Displacement. Okay. And look at the theta here. And this is the theta is the most important. Theta is what? I'm writing here. So this theta is the angle between, everybody should understand what is the theta. Theta is the angle between force and displacement. What is that? Force and displacement. Theta is the angle between force and displacement. Look at here. We wrote force here and displacement here. Force is a vector quantity and displacement is a vector quantity. They both will have directions. Yes or no? Tell me. Force is a vector quantity. Displacement is a vector quantity. Both will have directions. Depends on those directions, cos value will be related. Right? For example, if the force is in this direction, displacement also in the same direction. Look at the thing carefully. Force is in this direction, displacement is also in the same direction. What is the angle between them? 0 degrees. Yes or no? Yes or no? Force and displacement are in the same direction. The angle between them is 0 degrees. So for example, this is the force direction. So where I can write, so look at here, let me write here. So this is the force direction and this is the displacement direction. What is the angle between them? So the angle between them is 90 degrees. Is it clear? Everyone, force and displacement, the angle between them is 90 degrees. So now, if this is the force and the displacement is directed in this way, what is the angle between these two? This is force and this is displacement. So the angle between these two will be 180 degrees. Clear? So that value, the angle between force and displacement will be substituted here. Okay, if it is 0 degrees, the force and displacement are in the same direction, the theta will be 0 degrees, cos 0 will be how much? Cos 0 value you get from this tabular form, cos 0 will be 1. Done? Clear? For example, if the angle between force and displacement is 90 degrees in this way and the theta will be 90 degrees here, cos 90 degrees from the tabular form. What is cos 90 degrees? So cos 90 degrees will be 0. Alright? Now, when the force and displacement are in opposite direction like this, force and displacement are in opposite direction. The theta value is what? 180 degrees, and this 180 will be substituted here. Cos 180 degrees is how much? This is not there in this tabular form. I told you in higher level trigonometry you will be getting this, but for our topic called work, the cos theta is very important, and that's the reason I will give you the values of cos here. Cos 180 degrees is equal to minus 1. Remember this. Cos 180 degrees is how much? Minus 1. Cos 180 degrees is how much? Minus 1. Right? In assignment, there will be a question based on this 180 degrees. Remember today's assignment. Cos 180 degrees is how much? Minus 1. Is it clear? Done. So while we have discussed the basic trigonometry is just to understand the cos values, because in our work done by a force expression, it is force, displacement and the cos angle between force and displacement. It is there. Cos theta is there. Without learning these cos values, how you will understand this cos theta term? What is the theta here? Theta is the angle between force and displacement. Okay. Clear? Now, focus on cos values. Cos 0, 1. Cos 30, root 3 by 2. Cos 45, 1 by root 2. Cos 60, 1 by 2. Cos 90, 0. Three values are very important. Cos 0 is 1. Cos 90 is 0. And cos 180 is minus 1. These three values are very important. And let's start the concept called work done by a force. And students, now the name of the topic is work done by a constant force, right? What is the name of the topic here? Work done by a constant force. Once you start your first PUC topics, there will be a topic called work done by a variable force also. But now, about a variable force we are not discussing. About a constant force only we will be discussing right now. What is this work done by a constant force? I've told you already, you should not say simply work. You should say that work done by a force, right? So what is that? Look at here, a simple example I just wanted to give you here. It's a ground here. So there is a body which is kept here. This is the body, will have some mass m. We are not going to do anything with the mass right now. Just the body will have some mass. A force F is acting on it. Capital F is acting on it, which is a constant force acting on it. When there is a constant force acting on the body, there will be a constant acceleration. As constant acceleration is there, the body will speed up and moves to some particular distance after some time. The same body here, the body is traveled a distance at the displacement s here. Is it clear? The body is covered a displacement s because of this force. The question is so simple. What is the work done by this force? Look at here. So the question is work done by the force. Work done by the force is equal to what we have discussed, the formula. W is equal to force into displacement into cos theta. Clear? So what is this force? F as it is. What is this S? Displacement taken by the body. And what is the cos theta? Theta is what? Again I am writing here. Theta is the angle between F force and a displacement. Clear? So let me write the work done by the force in this case. W is equal to F. The force acting on the body, it's F. Yes, displacement taken by the body is S, and cos of, what is this angle theta here? Theta is angle between force and displacement. Force is in this direction, displacement also in the same direction. Displacement we must always measure from initial point to the final point. Okay, so this is the displacement direction. So force direction and displacement direction are same, then the angle between them will be 0 degrees. So I can say F as cos 0 degrees, right? So finally W is equal to F into S, whereas cos 0 degrees is how much? Cos 0 degrees is how much? Cos 0 degrees is 1. Okay, so that's why I have written Fs into 1. So W is equal to Fs. This is the reason most of the times, most of the students will be remembering the formula of work done by a force, which is force into displacement. Force into displacement. Clear? So the actual definition of the work done by a force I am going to tell you now. Right? Before that, let's see the units of the work done by a force. What is the unit of the work done by a force? Force unit is Newton. S is displacement. Displacement unit for what? Meter. So the SI unit is, look at here, the SI unit of work done is Newton meter. Okay, and 1 Newton meter is equal to 1 joule. This is represented with a symbol capital J. So finally, what is the SI unit of the work done? Joule. Understand? What is that? Joule. This is 1 joule is 1 Newton meter. Understand? So let's start the concept of work done, actual definition of the work done. So I am writing here, work done by a force is equal to, look at here, work done by a force is equal to what? Is equal to, this is force, right? So this is the force in the direction of displacement. Yes or no? When you are writing F into S, this F must be in the direction of displacement, right? What I am writing here is component of force component of force in the direction of displacement, component of force in the direction of displacement into, what is this S? This S is displacement. Is it clear, everyone? So that's a concept of force into displacement, right? This is the actual definition of the work done by a force. So units we have finished, and the actual definition is also finished, and this work done is a scalar quantity. This we had already discussed, right? Now the most important topic we are going to discuss now, the most important topic, and listen. So let's see the example numerical in which we will be learning a lot of concepts related to the work done by a force, right? So let me take, this is the ground. What I can say, it's a rough ground in the sense there will be a frictional force acting on a body. Now, there is a body of mass 2 kg. Listen here, 2 kg. On this body, there is a force acting here, F, which is equal to 5 newtons. Listen, 5 newtons is the force acting on a body. Because of this 5 newtons constant force, after some time, the body has reached to the displacement called 4 meters from here to here. Displacement called 4 meters. The question is, work done. This is the force I can say as an external force. Clear? So what is this force called? So this is the force, I can write it as an external force. Clear? So this is the force I am applying from outside. Maybe with a thread or with a wire or with a string or a spring, I am applying externally. So work done by the external force is equal to, what is the formula? Force into displacement. Again I am writing here F S cos theta, right? So what is this F here? F is 5 Newton into displacement is what? 4 newtons into, this is theta 0, understand? So cos 0 degrees is 1. From the tabular form you get it. So what is the final one? Work done by the external force is equal to 5 into 4 into 1. It's 20 joules. Joule or Newton? What is the work done by the force? SI unit. So SI unit of the work done by the force is joule. So that's the reason I wrote work done by the external force is 20 joules. Clear? Done? Everyone? Now, look at here. I've told you it's a rough surface. Rough surface means a frictional force will be there acting on a body. When the body is moving, you can see the motion of the body is in this direction. Opposite to that motion of a body, the frictional force will act on the body. So imagine the frictional force acting on a body represented with a small f, which is, look at here, which is 1 Newton. Carefully see. Which is 1 Newton, right? I told you, work done by a force. That force may be external force, frictional force, normal reaction, weight of an object, gravitational force, tension force, any kind of force. But work is done by a force, right? So now the question is, they mentioned about the friction. So work done by the frictional force. That's the question. Work done by a frictional force. What is the work done by the frictional force? Here they are asking about frictional force. So you need to write the frictional force into displacement. See, whatever may be the displacement, whatever may be the force, the displacement taken by the body is S. This is S into cos theta. Right? Now, let's write work done by the frictional force. I am writing here work done by the frictional force is equal to frictional force. What is the frictional force value here? 1 into, so what is the displacement here? Displacement is same 4 meters into, so look at here, cos theta, and it is cos When force and displacement are in opposite direction, I have told you clearly, this is the force, left side. Displacement, it's a right side. Clear? Displacement always measure from initial point to final point, right? So this is the displacement, initial point to the final point. Now, carefully see, displacement is directed like this and the force is directed in the opposite direction. What is the angle between them? I have clearly mentioned, when this is the displacement and this is the force, the angle between them is 180 degrees. So now let me write it's cos 180 degrees, and this is 1 into 4, it's 4. Cos 180 degrees is minus 1. Is it clear? Cos 180 is how much? Minus 1. Minus 1 into 4 is minus 4. And look at here, minus 4 joule is the answer. Work done by the frictional force is how much? Minus 4 joules. Right. Alright. Everyone, are you understanding? Now, work done by the another force, we are going to do it. Listen to me carefully. Any body in the nature you take, the first force acting on it will be its weight, right? What is the weight of the body here? We know W is equal to mass into acceleration due to gravity. If you consider that the acceleration due to gravity is 10 meter per second square, I'm just assuming it, right? So what is the weight of an object here? Tell me what's the weight of an object? So W is weight here. It's not work done, remember. So what's the weight of an object here? Weight of an object is also a force, right? So I'm writing here force, which is equal to, what is the downward force here? M into G, 2 into 10. It's 20 newtons. Is it clear? Everyone, 20 newtons. Is it clear? Everyone, listen to me carefully. F is equal to 20 Newton force. But the body is not moving vertically. The body is moving horizontally, because among all the forces, this is the force is dominating. This is the force is unbalanced. That's the reason the body is accelerating in this direction. Again, I'm telling you, listen to me carefully. This is 20 newtons acting downwards. That means the body should go down, but it is not going. Why? There is another 20 newtons force is balanced in upward direction. 20 newtons is weight of a body and 20 newtons will be balanced upward. So that is the force called normal force. What is that force called? Normal force. About normal force we will be discussing later. Just try to understand. As the body is moving horizontally, that also means the body is not moving vertically. When it is not moving vertically, that indicates vertical forces are balanced. How the vertical forces are balanced? In this way. One force is 20 newtons is downwards. Another force 20 newtons must act upwards. Then only vertically the body is at rest. Vertically. But horizontally it's not like that. Understand, horizontally, one side 5 Newton, another side 1 Newton only. The resultant force is 5 minus 1, 4 Newton. With the 4 Newtons, the body will be moving right side. Okay. Now the concept is, what is the work done by force of gravity? What is that? Force of gravity. Carefully see, what is the work done by the force of gravity? Force of gravity is nothing but the weight of an object. Force of gravity is what? Weight of an object. There's another name for weight of an object is force of gravity. Work done by the force of gravity, which is equal to force. What is that force? Weight of an object. Understand? Which is into displacement into cos theta. Let me write weight. See, work done by the force of gravity. Understand? So Fg, let me write force of gravity, which is equal to F. What is the force of gravity here? 20 newtons into displacement. What is the displacement here? 4 meters into cos. Tell me the angle between force of gravity and displacement. This is force of gravity and this is displacement. What is the angle between this force of gravity and displacement? Is it 0 degrees? Is it 180 degrees? Is it 270 degrees? No. The angle between force of gravity, look at here. So, see, the force of gravity, this is force and this is displacement. The angle between them is 90 degrees. It's cos 90, right? So, this I can write 20 into 4, right? It is 80 into cos 90 will be 0. So, the answer is 0 joule. Carefully listen. If they ask you the question, work done by the normal force, where is the normal force? This is the normal force. This is the displacement. Here also the angle you get 90 degrees. The 0 joule, you also get the work done by normal force is also 0. Understand? Work done by the force of gravity is also 0. What you should understand from this concept is, there are 3 types of work done. How many types of work done? There are 3 types of work done. In the next class, we will be discussing much more detailed way about 3 types of work done. Number 1, positive work done. Look at the positive work done here. It's 20 joule. Understand? Now, negative work done. So, this is the negative work done. You can see minus 4 joule. What is that? Minus 4 joule, negative work done. And there is a 0 work done also. And this is the 0 work done. Right? 0 work done. Carefully see. Positive work done, negative work done, and 0 work done. So these all the things are mostly depending on what? The mostly depending on your cos theta values. So when this is cos 0 and you get it is 5 into 4 into 1. And when this is 180, cos 180 you get minus 1. Right? So here cos 90 is 0. So mainly your work done by the force is depending on the theta value. What is theta? Again I am telling you, this is 5th or 6th time I am telling you in this session. Theta is the angle between the force and displacement. Right? So finally the conclusion here, there are 3 types of work done. Positive work done, negative work done, and the 0 work done. Positive work done is possible when force and displacement are in the same direction. Negative work done, you get it when force and displacement are in opposite direction. And 0 work done you get when force and displacement are in perpendicular to each other. About types of work done we'll discuss in the next class. So finally, what I just wanted to tell you is W is Fs cos theta, right? So the work done by a force is depending on 3 important factors. So on the force, on the displacement, on the theta value, right? Work done by a force depending on how many factors? 3 factors. On the force, on the displacement, on the theta, which is angle between force and displacement, right? So practice well, take some time and prepare all these things once again, write the notes neatly, then attend your today's assignment, right? So hopefully we'll meet in the next session with a topic called types of work done by a force.